This is tutorial question 1. A 3 meter wide, 8 meter high rectangular gate is located at the end of a rectangular passage that is connected to a large open tank filled with water as shown in figure 1. The gate is hinged at its bottom and held closed by a horizontal force Fh located at the center of the gate. The maximum value of Fh is 3,500 kilonewton. Determine the maximum water depth H above the center of the gate that can exist without the gate opening. And B, is the answer the same if the gate is hinged at the top? Explain your answer. So in this question, we have a tank like this. So and then we have a water gate at the end of the passage here. So and then this water gate has hinge, means that if the force push to the right here, so it will open like this one. So to make sure that the water not leak from this passage, so we need to hold the gate by pushing them from right to the left with certain amount. So according to this question, we need to hold for 3,500 kilonewton to make sure that the water is not leaking. Okay, and now we need to calculate the value of H here, which is the distance, the vertical distance from the free surface to the center of the gate. So means that this is the submerged area and this will become the centroid of the gate. So and then please bear in mind we have a horizontal force which acts from right to the left. So this is the external force. So external force means force that we give to the system. It is not a natural force that occur where because of water is filled in this area. So means that this external force can be act freely. So you could act on the centroid, you could push it at the top here, you could push it at the bottom here, and also you could push it with any direction you like, because it is not compulsory to be drawn perpendicular. However, for the force that comes out from the water here, it is the natural force that comes due to the pressure. So we need to draw the force is perpendicular to the surface, and then the resultant force must be below the centroid here. So and then we could calculate the value of Fr like this one, rho GHCA, and then the H here, the HC here is equal to the H. You may refer to the diagram here. The value of H is from the free surface to the center of the gate. So mean this is equal to HC. So we could have H here, and then the area is the submerged area. We only focus to the gate. So the height is 4 plus 4 and the width is 3. So we could calculate it is equal to 24 H. So and then we need to calculate the value of YR. So the equation of YR is moment of inertia divided by YC times A plus YC. So the moment of inertia here, you need to understand that we have a rectangular gate. So means that you need to imagine, so we have a rectangular gate like this one. So let's say we have this one, we have a rectangular gate. So and then the height is 8 and the width is 3 meter like this one. And then we have a hinge here at the bottom here, we have a hinge. So normally when we have a hinge here, so we assume that this is the axis. So means that if the gate start to rotate, so it must fix on the hinge here. So mean it will rotate whether this direction or that direction. So according to this location of this axis, okay, we could write the moment of inertia for rectangular is 1 over 12 times the distance here need to be power to the 3, and we multiply with the length here, which is 3. So we could calculate it as this one. So 1 over 12, 3 times 8 to the power of 3. So we divide with YC according to this diagram, because the water gate here is vertical, so mean the location of HC here is equal to YC. So we substitute the value of H here, and the A is 24, and we plus with YC, which is equal to H. So we have this equation. So, and then according to this application, we have a hinge here. So means that if we have a hinge here, and then if we have a force apply on these two object, so the object will rotate. So this rotation or this problem need to be solved in with the idea of moment, rotating moment. So the idea of rotating moment is force times distance. So please bear in mind, if you have an object here, and then you have a hinge here, you have a force 1 and force 2 here. Okay, let's say this is F1, this is F2. Okay, the equilibrium moment in rotating moment is, if we have x1 here and then we have x2 here, so you may write that F1 times x1 is equal with F2 times x2. So this is the rule of the moments. So I hope you could understand this one. And the distance here must be perpendicular to the force. So, and then we draw the diagram. So this is the centroid. Okay, so this is the horizontal force given from the equation, and this is the resultant force, which acts a little bit below from the centroid here, and this is the hinge. So this is the distance L. So, and the distance is 4 meters. So this 4 meters is actually based on this diagram. So, and then in equilibrium, we could say that Fr times L is equal to Fh times 4. So, however, from our previous calculation, we only managed to get the value of Yr with this equation. So, and then according to this one, so if we have a force X here, so the Yr means distance from here to here. So this is the YR. The problem is we need to calculate using the distance from this point to this point. So in this situation, you need to solve this by using the mechanical engineering idea. So you need to, by hook or by crook, you need to get equation about this length. So let's say this is dl. So you need to create your own equation for this length. So, and then I simplified the calculation. So later on you will study by your own. The value of L here can be written as H plus 4 minus YR. So what we need to do, we just substitute this value into this one, and then we substitute the value of YR here with the value that we get in this calculation. So, and then we could calculate the value of H is equal to 16.2 meters. For the next question, we need to calculate the value of H if the hinge is located at the top here. So in this situation, it is okay for us not to calculate the value of Fr and Yr because we still could use the previous answer of Fr and Yr. And then from this diagram, we develop the force equilibrium in terms of rotating moment. So we could write this equal to F times R, Fr times L, which is the L here is the distance from the hinge to the Fr here, is equal to the horizontal force times 4 meter here. So again, we need to determine what is the value of L, because according to this one, so we have Fr here. So we need to calculate the distance from here to here only. So the YR is the distance from the top to the FR here. So this is the YR. So we need to deduct a certain amount here. So it can be simplified as this one. So the L is equal to YR minus H plus 4. So this equation is depend on the diagram. So we substitute the value of L here into this one. So and then we could get this equation. So and then we substitute the value of YR according to our previous calculation, which is this one. Okay, you substitute all this value into this equation, so you will get 13.5 meters. So from this both value, we could conclude that the maximum depth for gate hinge at top here is less than the maximum depth for gate hinge at bottom.